Alrighty, so today let's work on a lead code question, all right, which is a very good preparation for your user code exam here. And that question is number 70. Number 70 is climbing stairs. This is an easy question, but it can be pretty challenging as well. All right, okay. So first off, all right, you are climbing a staircase. It takes n steps to reach the top. Each time you can either climb one or two steps. In how many distinct ways can you climb to the top? All right. So, uh, good news is the question itself is very clear, I would say. Not tedious, not cliche, no yada yada. So it gives you two options. One option is one step every time. Another one is two steps every time. And it wants you to find how many ways, or yes, different ways. It has to be different ways that you can climb to the top, right? Okay. Uh, Now the concept is very like user code, right? So firstly, you see, all right, um, there should be more than one ways, and then but how many ways, right? So therefore, we love to step into the question by checking out some sample cases, right? So this is how usually we start any algorithm related to the questions here. So April 12th, right here. So this is one of the question itself. I'll be just importing all the data here, right? Okay, there we go. And let's dive into it. Good. All right. So basically, the way to solve any algorithm, related question, um, questions um, can be um, can be classified into three steps, right? Okay. Usually step one is um, understanding the questions by listing. Uh, Usually it's going to be three sample cases, right? So why it makes sense if you are able to list manually, right? Manually list something, right? This is manually listing three different sample cases, right? That's, I guess, simply that means you quite understand the question itself, right? Okay. Uh, and step two is basically what? Step two is usually implementing uh a sample code, right? All right, it's like a pseudocode. Either on whiteboard, or paper, or just a compiler, right? And step three is basically just uh, if step one and two work, right? This is the precondition. If step one and step two work, then well, polish um, the algorithm, right? Okay. Then usually, and if not, right? If not, redo, right? Do step one and two, step two again. As you can see, this is also an algorithm, right? So if something is true, then yeah, you're on the right track. If it's not, then well, please go back to the step one, step two, do it again, right? Okay. See, well, most people think algorithm just for computer programming, but I would say it's basically everywhere. It's in your life, right? It's like problem solving. Okay. So now let's check these questions again, right? So this is a question, right? It gives you a sample case n is 2 and the output is to y is 2. It is because there are two ways to climb to the top, but you definitely want to ask why, right? So then now is a very good time to list all the possible not possible, like maybe one, two, three, right? Okay. So for instance, uh All right, so if n equals 1, all right, what is going on? So there's just the one way, right? So therefore, it is going to be 1. And if n equals to 2, all right, just to think, you can do 1 and 1, right? And then it is going to be, this is a one case, right? This is a one case. And you can also do 2 steps, right? So totally, it is going to be what? Totally, all right? Totally is going to be overall. How many? All right. Totally, this is going to be overall 2, right? So there are 2 operations here, right? Okay. So there we go. Um, and what if there are 3? So then it is going to be a little bit different, all right? So first, you definitely you can use 1, 1, 1, right? Oh, and I guess you've realized one thing. So uh, it is guaranteed one solution for sure, right? It is guaranteed one solution for sure. And if you think this is a little bit difficult to understand, so I would just use like, okay, I'll be using like 1, 2, 3, right? So different layers. And therefore, it turns out to be there are 2, right? Okay. And what if there are 3? So immediately you put 3 ones here, right? And then next one is going to be what? So uh, you can do 1 and 1 and 2. No, all right. But how about these? I guess it works, right? And then how about these? It works as well because there are 3, right? Okay. So now as we can see, so does order matters? So now you want to think by yourself is, okay, does the order matter? Yes, it is, right? Because what? Because uh, 1 and 2 is not equals to 2 and 1, right? Okay. So then it is possible you want to think of maybe permutation, right? Probably it's a permutation. Um, I guess it makes sense, right? Okay, it's about the permutation. You can pick only 2 options from the data set, right? Okay, but it's possible. It is possible, maybe possible, right? Okay. And then right now, what do you get currently is, all right, I have 1 and a 2 and a 3. And it looks like, I mean, it doesn't make too much sense, right? Okay, so right here, it is going to be, there are 3 of these, right? Just to make it a little bit better. So right here, yes, I'll just put next to line. Let's see that. Right, okay. Now we have 1, 2, 3. And then why don't we do another round, right? So therefore, all right, because 1, 2, 3, you wouldn't possibly figure out the pattern, right? Because okay, so 1, 2, 3, how about 4? So what is it that is going to be a 4? Then yes, you immediately put 1, 3, 1, 4 ones here, right? And then you start to kill all the ones by 2, right? Okay, so then you have 1, 1, 1, and a 2. It makes sense. And then how about I guess I really want to make this in one line, right? So you have 1, 1, 2, and how about 1, 2, 1? Makes sense, right? And then how about what? So then I guess it finished with that, but you can also have the 2, 1, 1, right? Okay. And then how about the 2 and a 2? Yeah, it makes sense, right? So how many data here? 1, 2, 3, 4, 5, right? You have 5 data here. So then it turns out to be, okay, there are 5. Okay. So now, all right, so this is the result, right? AR is right here. But then you keep updating it. So you keep updating it. So now you have 1, 2, 3, 4, and a 5. So now, all right, what is going on if there are 5 stairs? What is going to be the pattern, right? So then it keeps exploring, right? So then I guess you figure out 1, 2, 3, 4, 5 immediately, right? I guess you just put 1, 2, 3, 1, 2, 3. No, right? You put a 1 here, right? Okay. And then this is a 5, right? And then right here, what else you can do is a 2, 1, 2, right? And then how about 1, 2, 2, right? Okay, because you can also reverse this, right? And then move one in front of it, right? Okay. And then I guess now we need to fill out maybe right here, 1, 1, 1. Okay, I have how many? 3 ones here. And then immediately I can reverse it, right? So 1, 2, 1, 1, 1, right? And then in the middle, I can do 1, 1, 2, 1, right? And then what? 1, 2, 1, 1, right? Okay. And I guess I finished 1, 2, 3, 4, 5, 6, 7, 8, right? This is all the possible combinations here, right? Okay. So therefore, it turns out to be there are 8, right? Then you know what? I'll be updating my array real quick. So then I see, okay, I have 1, 2, 3, 5, 8. So now it it makes me think if it is a Fibonacci sequence. Hello, Alex. Have you ever studied the Fibonacci sequence before?
No.
All right. Like so, yeah. So math plays an important role, right? So therefore, Fibonacci sequence is f0 equals 1, f1 equals 1, and f2 equals f1 plus f0, right? And then in turn turns out to be fn equals fn minus 1 plus fn minus 2, right? So this is a very famous, well-known sequence. It plays so many roles in modern civilization as well. All right. So therefore, it gives me an idea. So maybe it is just a Fibonacci sequence, right? So therefore, I'll be just implementing something here. So for instance, this is a recursion, all right? Recursion. So I need to do what? So if something and then also something here, right? If what? If n, all right, because it starts with 1 and 2, right? So if n less than maybe 3, right? Okay. Because n is 1, then it's 1. N is 2 is 2. 3 is different, right? 3 you need to calculate a little bit. So for this, it will just return itself, right? Okay. And how about else? Else, you just need to return climb, climb the stairs, right? And a plus. Or I'll just copy it there, just in case. This one is n minus 2, and this one is n minus 1. And if I submit this, I guess I'll be getting partial credits for sure. It is simply because it is just a Fibonacci sequence, as you can see, so 31 out of a 45, all right? And the problem is a time limit exceeded, right? Okay. So now I want to know how would I possibly solve this problem? Okay. So I see, all right, I needed to do what? I needed to have a vector, right? Okay, vector is an integer, and I need to have something called q or q, right? And then I guess this is all I need. And or I can assign some initial value here, 0, 0, 1, 2 here, right? Okay. And then I actually need a for loop here for integer I starts at 0, I less than just being lazy, so I can I think I can use n for sure, right? Yeah, equals to that, and then I increments. Right here actually starts with a 3, right? Okay, it is because I'm checking 0, 1, 2, and a 3, right? Okay, and then I also need to have a maybe I think I can maybe use the what do I do? Maybe results, right? Starts with a 0, right? Okay. And then what do I do? So if firstly, all right, I have something because I have the formula which is Fn equals Fn minus 1 plus Fn minus 2, right? So therefore, right here, I supposed to have Q I minus 1 and a plus and plus Q I minus 2 for some reason. Yes, it is for some reason. I can also save that somewhere else, or maybe I would just use a result replaced by that. Probably, right? I guess it is also possible, right? Okay. So now, and then what do I need to do? I also need to use a Q period push back, right? Push back what? Push back the current I guess. Do I do that? If I do that, I think no. I think I need to push back a rest, right? Okay, so therefore it has to be maybe if after that, right? So then I can test my algorithms here, right? So this is exactly step two, right? Okay, this is exactly step two. So step two, I have okay in the first round. So round one, right? Um, round one. Okay. Suppose I have three, right? Suppose I have three. Round one, if n equals to three, then the loop will work once, right? Okay. And then I have what? So the rest equals qi. So q right? And a plus q what? Q1. And that is a what? Q1 is one plus two. Then I have three. Yes. Then I have three. So therefore, like things right here, I can return rest. So if the three, then it's a three, then it's a good result, right? And I also push this one into it. So therefore, next time I have three here, right? So I guess probably it makes sense, right? So then right here, round two, if the n equals to four, right? The loop will work twice, right? Okay, will work twice. So in the first round, this is the same. So I have three, right? So this res one is a three, and then res two is the same format as here, but it is going to be now it's a three, right? This is a two. Three, I I just made it, right? So I have three here. I have three, and then two I do, which is two, right? Three plus two, I have five. So therefore, it looks pretty good to me now, right? So I have five here, four, I have five here, right? So maybe I just want to give it a go. So let's see what is going on. Hmm. Semicolon. Run the code one more time. Okay, I have some wrong answers here, but I also have a good answer here. Okay, three is a three, but n is two. I have two. Output is two. Okay, interesting. Uh, oh, you know what? I think I need to do this, right? So if yes, if the basic cases, right? So if n is less than three, it will just return itself, right? Okay, I forgot this very basic stuff here. Let's see what is going on, right? So we agree that in previous samples cases, right? So then let's submit that and let's see what is going on. Then boom, 100%, right? Okay. So this is exactly what I mentioned before. It is just as step one, two, and a three, right? See, if step one and step two work, then polish the algorithm. If not, do that again, right? So um, I do this or I do that, right? So if because it's not working, so then I try, oh, I forgot this, right? Then boom, it's done. Okay, there we go. And now I have 100% here. Good. So this is a very good example here. So this is a very good example here. I guess you can tell. So in order to solve this problem, you probably need to spend like 30 minutes to think it over, right? So like how this, if you don't spend 30 minutes, it is not very possible you solve this problem by yourself, right? Okay. 30 minutes is a good timing. It's a good timing. So you got to spend this amount of time. Otherwise, you either know the question already, or somebody do the question for you, right? Okay. Um, Uh, I guess it makes sense. Okay, there we go. Good. So right now, I want you to work on this question a little bit by yourself and use this timeline. All right, step one, two, and three. And you probably want to spend probably like 40 minutes or yeah. Okay, do the question again, right? So suppose you didn't see this question before, how would you solve this problem, right? Good. Okay, I'm going to send you the problem link. All right, and I'm going to allow you to work on this. Currently, do you have any questions? Like anything confuse you?
What confused me?
Yeah,
No, like about what'd you say, like for your question?
it's like which part is you don't understand?
Um,
Maybe I guess you just need to read it through and give me some feedback later, probably.
okay.
Good. All right, good. But it makes sense, right? It makes sense, right?
Yeah.
Good. Then it is a good response here. All right, so now I want you to share your screen and therefore work on these questions. All right.
Okay. So, wait, okay. Let me take a good look.
Let me share my screen one more time. So now this is going to be lecture practice. All right. So firstly, read through the problem solving flow. And secondly, read through the questions. Number three, read through the algorithm solution. Number four, uh, solve the problem by yourself. Then you want to do the same that I did, such as manually list some sample cases and implement sample code, and then do the three steps basically. All right. Okay. Do you have any questions so far?
Uh, I don't think so.
All right, good. Then you can share your screen and I'll be checking your work.
Okay. I'm gonna go blow my nose for a second. Be right back.
All right. All right, Alex, let me know if you're back, all right?
Yeah, I'm back. I'm working on it.
Good. And making sure you share your screen, so therefore I'll be knowing what you're doing.
Okay. Let me share my screen.
Good.
Are you C++ or Python?
I recommend you use the C++ first. Whenever you use the C++ and solve the problem easily, you can easily switch to Python because C++ is always better, right? Good. Oh, use the C++ and Python both, all right? Okay. Makes
Okay.
sense, right? Good. Therefore, you practice twice, which is a good. You double it. Okay. Let me grab a coffee. I'll be right back, all right?
Hello. I finished it. Hello. Oh, oh, hello. Hello.
Hello, Alex. Everything good?
Yeah, I finished it.
Good. All right. I'm going to allow you to share a screen again. So I want you to solve the problem again lively. All right. I'm going to record it. So be ready for it. All right.
Okay, let me share my screen.
All right. And also, I'm going to update a picture. That is a whiteboard. Whiteboard. What is it? Nope. Never mind.
Huh?
Hold on.
What? What whiteboard?
What's that?
What whiteboard?
Just give me a sec. All right, here we are. All right, so let me share my screen first. All right. Okay, okay. Am I sharing my screen?
Yeah.
Good. So this is the whiteboard. I just made a whiteboard for you. All right. So when you're doing your programming, you can use these as a reference here, right? So today is April 12th, right? Algorithm, climbing stairs, case one, two, three, and all of these here, and then you do all of these here. So if you don't use a whiteboard, I recommend a paperwork. So therefore, you just follow your paperwork and do the programming stuff. Okay, makes sense. So right now, I'm going to stop sharing mine, and please share yours. And I want you to work on that live. All right? Okay, good.
Yeah.
I'm going to
Well,
resume. All right. So in three, two, one, here we. Semicolon, another semicolon. Good. All right, submit. That's good. All right, see,
okay.
works, right? Good. Well, even though it's an easy question, but actually there's so many things inside this question. All right, good job, man. Okay, do you have any questions?
No.
Good. All right.